Let's look at some sample problems from section 4-3 dealing with the addition rule. And these exercises begin on page 153 in our textbook. And I'm going to start with number 6. And it says, for these exercises, determine whether the two events are disjoint for a single trial. Consider disjoint to be equivalent to separate or not overlapping. So number 6 says asking for a date through a Twitter post, asking for a date in French, the Romance language. Are they disjoint? So because of the fact that we could ask for a date through a Twitter post in French, it's not disjoint. It can occur at the same time. Okay, let's look at number 8. Randomly selecting a statistics student and getting one who uses a TI calculator in class. Randomly selecting a statistics student, getting one who uses StatDisk, the StatDisk computer program. Okay, again, these could occur, you could find a student who does both, who uses a calculator, the TI calculator, and also StatDisk. So this one's not disjoint, or not mutually exclusive if you want to use that term. Number 10, randomly selecting a drug screening result and getting one that is false positive. Randomly selecting a drug screening result and getting one from someone who uses drugs. Okay? So a false positive would mean the person did not use drugs, whereas we're being told that they were getting the results from someone who uses drugs. So that would have to be disjoint. We can't have someone who both doesn't use drugs and also uses drugs. Number 12, randomly selecting a drug screening result and getting one that is false positive. So that's a person who doesn't use drugs and there's a positive result. Randomly selecting a drug screening result and getting one that is false negative. That means we have someone who does use drugs and it falsely says that they don't. So one that doesn't use and one that does use, again, would be disjoint. Okay, number 14. According to the National Association for College Admissions Counseling in USA Today, 19.8% of college students take at least one class online. What is the probability of randomly selecting a college student who does not take any college online courses? So we know the probability of taking an online is 0.198. So probability not online would be 1 minus 0.198, which would give us 0.802. So we're using the complements rule. Okay, number 16. When the author observed a sobriety checkpoint conducted by the Dutchess County Sheriff's Department, he saw that 676 drivers were screened and 6 were arrested for driving while intoxicated. Based on those results, we can estimate the probability of intoxication is 0.00888. Where I denotes the event of screening a driver and getting someone who is intoxicated. What does P of not I denote? So that would be the probability someone's not intoxicated when they're screened. And we would calculate that as 0.99112. And if we round that to 3 decimal places, we get 0.991. Okay, in number 22, we're going to be using dosage calculations. It says use the data in the accompanying table, which lists the numbers of correct and wrong dosage amounts calculated by physicians. In a research experiment, one group of physicians was given bottles of epinephrine labeled with a concentration of 1 milligram in 1 milliliter solution. And another group of physicians was given bottles labeled with a ratio of 1 milliliter of a 1 to 1,000 solution. The two labels describe the exact same amount, and the physicians were instructed to administer 0.12 milligrams of epinephrine. The results were reported in the New York Times. So we have correct and wrong dosage calculations, one from the concentration label and one from the ratio label. Okay, so in 22, if one of the physicians is randomly selected, what is the probability of getting one who calculated the dose incorrectly? Is that probability as low as it should be? Okay, first of all, we need to figure out how many people we have in this table. I don't think they told us. So we have 13 plus 15. So we have a total of 28 physicians in the table. How many did it wrong incorrectly? It would be the 3 plus the 12. So probability wrong is 15 out of 28. Wow, more than half. That's not very encouraging. As a decimal, it would be 0.536. It's a 15 there. Okay, so it's pretty high, and it's certainly not as low as it should be. Okay, so number 24. If one of the physicians is randomly selected, find the probability of getting who made a wrong dosage calculation or was given the bottle with a ratio label. Okay, we have 15 who did the wrong, plus 2 more that were given the ratio label who got it correct. So 17. And I'm using intuitive approach there, so I get 17 out of 28, which would be 0.607 if you did it as a decimal. Let me circle both answers here. Okay, let's move on to 26. For the physicians in the bottles label but with a concentration, find the percentage of wrong dosage calculations, then express it as a probability. So 36A okay, with the concentration that we have total of 14, so 3 divided by 14, 3 divided by 14 is 0.214. That would be the probability. The percent would be 21.4%. Okay, for the physicians given the bottle labeled with a ratio, we have 14 there as well, and 12 of them were wrong, so 12 out of 14. 12 divided by 14 gives us 0.857. So 85.7% of them got it wrong. All right, and part C, does it appear that either group did worse? Okay, C would be the ones with the ratio were worse. So that would indicate they should go with a concentration label. Okay. All right, now we have another table. Refer to the following table summarizing results from a study of people who refuse to answer survey questions, and they tell us where it comes from. In each case, assume that one of the subjects is randomly selected. Okay, so 28. A pharmaceutical company is interested in opinions of the elderly because they are either receiving Medicare or will receive it soon. What is the probability that the selected subject is someone 60 and over who responded? Okay, so the first thing we need to do is figure out how many people we have in this table. And so we need to add the numbers quickly. And I got 1205. Total surveyed is 1205. Okay, so we need to know that. So, someone 60 and over who responded. So that probability would be 202 out of 1205. 202 divided by 1205 is 0.1676, so that would be 0.168. All right, and number 30, what is the probability that the selected person refused to respond or is over 59 years of age? Okay, so refused, we need to add up all the refusals. 11 plus 20 is 33 plus 16 plus 27 plus 49 plus the ones that responded in the over 59 group, 202. Okay, I'm getting 358 out of 1205. So I divide that out on my calculator and I'm getting 0.297. Okay, number 32, a market researcher is not interested in refusals or subjects below 22 years of age or over 49. Find the probability that the selected person refused to answer or is below 22 or older than 59. So I need the 73 plus all the refusals. It's 27 plus 49 plus the ones that are over 59. So I got 431 over 1205. And what I want to do is divide that out. Whoops. And I'm getting 0.3576, so 0.358.